Good evening, everybody. Welcome to week 6, day 3. Let's jump into the work. MCQ number 1. MCQ number 1. The potentiometer circuit is set up as shown in the figure. When the galvanometer is connected to point A, and B respectively, the balance lengths are 75 centimeter and 300 centimeter. Now what's happening here is primary circuit, there is a current passing through. Primary circuit, there is a current passing through. Secondary circuit, there is a current passing through. At the balance point, the currents don't mix. Maybe any other time that this current will come here, this current will go there, there will be a mixture of currents. But at the balance point, currents don't mix. Primary circuit current and secondary circuit current will not mix. Now, if you take at point A, the balance lengths are, so if you look at this carefully, potential difference is balanced here. So I2 R1 is proportional to the balance length 75. Next what? At B, that means I2 R1 plus R2 is balanced here 300 centimeters. They are asking the ratio R2 or R1, so let me divide the second equation by the first. I2 R1 plus R2 divided by I2 R1, 300 divided by 75. I2 will cancel off. If you look at this carefully, R1, here ratio 1, here R2 over R1. Simplify, 25 times 3, 25 times 1, 50 we have 2, 4. From this you can say R2 over R1 is 4 minus 1, which is 3. Answer is answer number 5. So this is your primary circuit. This is your secondary circuit. Primary circuit, secondary circuit. Right there. At the balance point, the primary circuit current and the secondary circuit current will not mix. The primary circuit current and the secondary circuit current will not mix. Primary circuit current and the secondary circuit current will not mix. And in a potentiometer, the potential difference is proportional to the length. Okay. Potential difference is proportional to the length. Okay. Right. Moving forward. A sphere M is whirled around a horizontal circle, keyword horizontal circle, constant speed. The forces acting on the sphere observed by a person who is at rest. Somebody outside, that means like you and me. So we can see the tension, we can see the weight, that's all. Component of the tension will give the centripetal force. The component of the tension will give the centripetal force. So somebody at rest will see only tension and mg acting. So your correct answer is answer number 2. Right. A PN junction is connected to a battery as shown. Now, is this forward bias or reverse bias? Looking at this is of course reverse bias. Why? Negative terminal is connected to the P type, positive terminal connected to N type, so the reverse bias. Reverse bias means minority charge carriers will come into effect. But there are some diodes which work for reverse bias. Photodiode is something like that. Photodiode, solar cells, all these work at reverse bias condition. Also xenodiode, famously xenodiode. Right. When light is shone on the junction, electron hole pairs are created. Photodiode. Light falls on the p-n junction, causing electrons to come out emitting photons. Right. So here, creating absorption of photons. Current in the circuit is produced by the incident light. Okay, no? So the bonds are broken in the barrier region. Right. So what are they saying? Due to electrons moving in the direction of n to p, holes are moving in the opposite direction. So again, what condition is this? Reverse bias. So photodiode works according to the reverse bias condition. And photons fall to the barrier region. Photons are falling, or light is falling to the barrier region. Right. Have a look. Due to electrons moving in the direction of p to n, and holes moving in the opposite direction. So what will happen? Now here barrier region is created. Pn, clear? Pn. Near the p-type semiconductor, n-type semiconductor, here you go. So what happens is, when light falls on the junction, from the bonds are broken. If I draw it here, the bonds will be broken. Bonds are broken. Hole is there, electron is there. Electron is accelerating towards the positive charge. Electron will accelerate towards the positive charge of p-type, or the positive chargeness here. Holes move in the opposite direction. Okay. So holes are moving in the opposite direction means electrons are going this way, means current is going in the opposite direction. Holes are going that way. There you go. So due to the electrons moving in the direction of p to n, and holes are moving in the opposite direction. Second one is correct. So when light falls on the p-n junction, the bonds are broken, electron hole is created, electron will accelerate towards the positive charge side, holes will go towards the negative charge. Why? Electrons are negatively charged, according to electric fields, attracted towards the positive side. Holes are positively charged, attracted towards the negative side. So electrons are going from p to n, holes are going from n to p. So electrons move p to n, holes move n to p. Correct answer is answer 2. Right. A thick wire A and a thin wire B are made from the same material, keyword same material, and are connected to the battery in series as shown. The lengths of the two wires are same, that's also keyword. What can you say? Resistance proportional to L over A. Thickness is large means resistance is small. So resistance of A is going to be smaller than resistance of B. Both have the same resistance, A is wrong. Drift velocity of electrons in A is smaller than that in B. Drift velocity I is equal to ANEV. Drift velocity is equal to I over ANE. Whatever happens, same current will pass through. Now same material, number of electrons per cubic meter is same, charge of electron is same. Drift velocity is proportional inversely to A. Drift velocity A is smaller, larger A means smaller VD. Be correct. free electron density in A and B are different. Free electron density means number of charges per cubic meter. Both are same. Same material. Number of charges per cubic meter same. C wrong. Only B is correct. Answer number 2. Answer number 2. Right there. In the same material, the number of charges per cubic meter is the same. The number of charges per cubic meter is the same. The number of charges per cubic meter is the same. Right. Carefully look. Figure shows force to extension graph. So these are under elasticity. Huh? Elasticity. Now we call this loop something called a hysteresis loop. Hysteresis loop. Actually what happens is the loading curve, when you're, let's say rubber band, you're pulling the rubber band and releasing the rubber band. Loading and unloading are in two different parts. The reason the loading and the unloading are in two different parts is there is some energy loss. Because when the rubber particles move on top of each other, they will rub on each other, creating friction. Heat is produced. Okay, heat is produced. Right. Rubber band does not return to the original length after the stretch. I think you can see that. After the stretch does not return. There is some strain hardening. A is correct. The magnitude of the total work done during the increase of the length is less than the magnitude of the total work done during decrease. That's wrong. Area under the graph due to loading is more than unloading. Statement B is wrong. Right there. Area under the graph during loading, is greater than the area under the graph during unloading. Is greater than the graph during unloading. Heat can be generated in this process, correct. A and C correct. Answer number 4. Right there. A hysteresis loop is formed in rubber because during loading and unloading, the paths are different. During loading and unloading, the paths are different. Because there is some energy loss due to friction. Okay, no? Right. Question number 6. The filament of 100-watt bulb takes 200 milliseconds to reach full brightness. Can you remember yesterday's work? Brightness is connected to potential difference. Don't forget. Huh? Brightness is connected to potential difference. When the bulb is connected across a constant voltage supply of 230 volts. Consider the following statements. Right. During 200 millisecond period, resistance of the filament bulb will increase. Now what is happening? When the temperature increases, you know the IV curve. IV characteristic curve is a curve like this. What is happening? 1 over R is reducing. 1 over R is reducing because resistance increases. Why? When the current is passing through, the coil will heat up. When the filament coil heats up, the resistance will also increase. Clear? Resistance will also increase. So what do you get from this? A is correct. During 200 millisecond period, power drawn from the supply decreases to 100 watt. Starting from a higher value. During 200 millisecond period, power drawn from the supply decreases to 100 watt. Starting from a higher value. C. Filament emits energy in the form of electromagnetic radiation. That is correct for sure. So A and C for sure correct. Think about B. Filament in the supply or filament supply there, that is 100 watt, 200 milliseconds. 100 watt, 200 milliseconds. So power is given, time is given. Power is given, time is given. Now, what is happening? Now here, if you think about it carefully, the moment you turn the switch on, current won't be constant. Current will increase to a maximum, then drop to a constant value. Yeah. So initially the current will reach a peak value. So here, if you look at this, I don't know whether they'll question you on this knowledge. So here to one, now the keyword here decreases to 100 watt. Actually, when you turn a switch on, if you take current and time, the current will increase to peak and then peak value. So this is normal process. So when the current increases, power output will also increase, then reach 100 watt. So in that case, if you think in that terms, this is correct. During 200 millisecond period, power drawn from the supply decreases to 100 watt. That means the power quickly will be given, it will drop to a particular value. So I don't know whether you'll have to think about this, but there is some additional knowledge. Additional knowledge, which is slightly out of your syllabus, because here you need to know something called inductance. I don't know whether the examiner actually meant what he asked here, but normally this basic common sense, forget about all of this. When you turn a switch on, current will increase and then drop to a fixed value. Okay? It will come to steady state. So anyway, A and C is correct. In my book, A and C is correct. But if you think about this, ABC is also correct. ABC is also correct. Yeah. So here, normally when you turn a switch on, current can increase to a peak value, then decrease to a fixed value. So it will be max and drop to a 100 watt value. Yeah. So this part is also correct, but this we don't talk in your syllabus, but the examiner has asked. But in terms of your syllabus frame, A and C is correct, guaranteed. But slightly out of your syllabus, this part, if you think basic common sense, practical, ABC is also correct. Right there. When we turn a switch on, the current immediately increases to maximum and then drops to a particular value. The current immediately increases to a maximum and then drops to a particular value. This means the power will be max and then drops to a lower value. Due to the inductance in the circuit. Due to the inductance in the circuit. But we don't consider inductance in our syllabus. But we don't consider inductance in our syllabus. So A and C is correct. A and C is correct. But also there is nothing wrong in statement B. Also there is nothing wrong in statement B. I told you the reason, no? Not in your syllabus, but there is nothing wrong. There is nothing wrong in statement B. Therefore, A, B, C all also can be considered. Therefore, A, B, C all can also be considered. Right. Okay, no? So I hope you understood for the second statement here, the thinking process. But A and C directly from your A-level physics knowledge, you can quickly write. This is something that is addition, but normally which happens. Okay. Right. A thin uniform wire PQ carrying a current I could be held without mechanical support above an infinite long RSY carrying in the current in the same direction. Mass per unit length is M. Mass per unit length is M, so weight per unit length is mg. Height is h. So currents traveling in opposite direction means there is a repulsive force. Force per length is mu naught I times I 2 pi h. 2 pi h. There. Force per length. So here if you look at it, mu naught I squared over 2 pi h. That is equal to mg. H equals mu naught I squared divided by 2 pi over mg. Mu naught I squared divided by 2 pi over mg. 2 pi mg. Seventh one, answer number 3. Seventh one, answer number 3. Right there. According to Biot-Savart theorem, if the currents are traveling, there will be a repulsive force. If the currents are traveling in the opposite direction, there will be a repulsive force. If the currents are traveling in the opposite direction, there will be a repulsive force. Force per length balances the weight per length. The force per length balances the weight per length. The force per length balances the weight per length. Okay. Right. A well-lagged Y-shaped structure made from copper has 3 identical limbs. Free ends of the 2 limbs are connected to a metal block which is maintained at temperature T1, like a reservoir, while the free end of the 3rd limb is maintained at temperature T0. The steady state temperature of junction P of the structure is, so heat will travel from here, go there and go here as well. Here temperature theta. So if you write this, Q dot 1 is Q dot 2 plus Q dot 3. Q dot 1 is equal to K times A T naught minus theta divided by L. K times A theta minus T1 divided by L. K times A theta minus T1 divided by L. Simple. So what do they want from here? They want, you can cancel off Ka, all the L's cancel off. Same temperature, copper, same length. Simplify this. T naught minus theta, theta minus T1 times 2. T naught minus theta, 2 theta minus 2 T1. T naught plus 2 T1 equal 3 theta. Theta is equal to T naught plus 2 T1 divided by 3. T naught plus 2 T1 divided by 3, answer number 5. Answer number 5. Okay. So this can be Q dot 1. This can be Q dot 2, this can be Q dot 3. Okay. Q dot 1, Q dot 2, Q dot 3. Right. The oxygen molecule 16 times the mass of hydrogen molecule. Right? At room temperature, root mean squared of oxygen. So root mean squared. Root mean squared is 3RT over molar mass square root. At what temperature? Room temperature is fixed. So root mean squared O2 proportional to 1 over molar mass of O2, root mean squared of hydrogen, molar mass of hydrogen, they are asking the ratio 1 divided by 2, root mean squared of O2 divided by root mean squared of hydrogen, turn upside down, molar mass of hydrogen over molar mass of oxygen, square root. So oxygen is 16 times more. 16 times means 104. 104 means answer number 4. Ninth one, 4. Okay, now? Right. MCQ 10. The figure shows the path of a particle X charged plus Q moving in the vicinity of another fixed particle charged plus Q. So positive charges will repel. They will repel. Variation of the speed of the particle X at distance D traveled along the path. So when it's coming here, there is going to be a repulsive force. No? If it comes here, closer it gets, the repulsive force is more. Closer it gets, repulsive force is even more. So velocity will reduce. But now it's going away, velocity will increase. Force is going to be there. So it reduces and then increases. Will it be 0? Never. So I think answer 3 is the correct answer. Initially, there will be a repulsive force. Causing the speed to reduce. But it will never be 0. Causing the speed to reduce, but it will never be 0. But it will never be 0. And as it moves away from plus Q, it will accelerate. As it moves away from plus Q, it will accelerate. Okay, right. Have a look. Question number 11. Crushed ice pieces at 0 degrees. Crushed ice. Remember, crushed ice contains water and are kept inside a thermally insulated closed container. Thermally insulated closed container. Nothing is coming from out. Nothing is going out. Heat is supplied to the container at a constant rate and the pressure inside the container is kept constant. Pressure is kept constant. The variation of the temperature inside the container is best represented with time. So crushed ice with water means 0 degrees Celsius. It will take some time to become water at 0 degrees Celsius. Water at 0 degrees Celsius. So can this take place? Well, this will not take place. Okay. Right. So have a small idea regarding latent heat of fusion. That's about 10 to the power 5, let's say, joule per kilogram. Latent heat of vaporization, 10 to the power 6 joule per kilogram. Right. So if you look at this carefully, here the heat supplied is the same, M over T LF, M over T LV. If you equate these two, supply is same. T2 over T1. Three over 20. T2 over T1. Sorry, opposite. Right. So both are equal. No? Both are equal. Let me simplify it like this. So M over T1 LF. M over T2 LV. T2 over T1 is LV over LF. 20 divided by 3, 6.67 more time ratio. So almost 6 times. So here 1.5 almost 7 times means 10.5 points. 10.5. If you look at this, approximately 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. Yeah, that's also okay. 1, 2, 3, 3.5. 3.5 means 7 times. 24. 1, 2, 3, 4, 5. Sorry. 1, 2, 3, 4, 5. This won't come. This one also won't come. Carefully observe this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here dot line is indicated. Now, if you are supplying heat continuously, crushed ice will become water at 0, 100 water, then 100 steam, 100 steam also temperature increases. So most suitable here, just looking at this ratio, 0.7, 7 times more. So compared to latent heat of fusion, 7 times more time is taken for vaporization. 7 times more time is taken for vaporization. That's just by this ratio. Having a rough idea about the ratio, you can quickly get the answer about the time. Okay. That's right. Since the latent heat of vaporization is greater than the latent heat of fusion, therefore the time taken to vaporize will be more than time taken for fusion. Time taken for vaporization will be more than time taken for fusion. And this time is 7 times more. So 7 times more time. So here it's going to be 1.5 here. 7 times more will be almost about 10.5, almost 11. Or slightly around that. Clear, no? Okay. Right. And of course, gradients can't be the same. Gradients can't be the same because specific heat capacities are different. Okay? That is also a point. Right there. The gradients are not the same. The gradients are not the same because specific heat capacities are different. Specific heat capacities. A uniform metal cylinder of mass m and spring is lowered. So this mass is m. When this comes down, there will be down thrust. So reading will increase. Yeah. So here what happens is reading will reduce. Here reaction reading will what? Increase. Reaction reading will increase. So it can't be the fourth one. It can't be the fifth one. So here constant increases, constant for a long time, touches the bottom, there you go. Correct answer is answer number 2. Right there. When we submerge the mass with the tension, when we submerge the mass with the spring scale, the tension will reduce. The tension will reduce until it's fully submerged. The tension will reduce until it is fully submerged. Tension will reduce until it's fully submerged. While the reaction scale will increase until it's fully submerged. The reaction scale will increase right? Right? So what happens here is very simple and direct. So reaction scale reading will increase. Keep writing. When the mass touches the bottom of the scale, when the mass touches the bottom of the scale, the string will get slack and the tension becomes 0. The string will become slack and the tension will become 0. String will become slack and the tension will become 0. String will become slack and the tension will become 0. And the reaction will increase further. And the reaction will increase further. So right now, here weight will increase, constant, then suddenly increase. Here tension will reduce. The moment it touches the bottom, string will become slack, it becomes 0. Okay, right. A metal block is suspended at rest below the surface of water in a tank. When the block is released, it falls to the bottom. So here this is the shape of water. I'm drawing. Now when it goes to the bottom, this is the shape of water. So here center of gravity would be somewhere here, center of gravity has gone out. So when the center of gravity of the mass comes down, the center of gravity of water will go up. So block loses gravitational potential energy is correct. Because when the block is coming down, the center of gravity of the block is also coming down. Center of gravity of the block is coming down means gravitational potential energy will reduce. Although the height of water level does not change, water gains gravitational potential energy. Correct. Why is that? When this comes to the bottom, the shape of the water has changed here. Shape of the water has changed. Earlier center of gravity, let's say, was somewhere here. Now the center of gravity is somewhere there. Center of gravity of water has gone up. Right there. Even though the level does not change, Even though the level does not change, the shape of the water has changed. The shape of the water has changed. Therefore, the gravitational potential energy of water increases. Therefore, the gravitational potential energy of water increases. Right? So, one is reducing, one is increasing. Right? If water was not present, kinetic energy of the block at point A would be less than that at A when water is present. If water was not present, so water was not there, kinetic energy of the block at point A. So kinetic energy, that means quickly it will fall, would be less than that when water was present. True or false? There was no water. Let's say it's falling in air. When it's falling in air, what will happen? When it's falling in air, velocity will be more. Water will cause fluid friction, velocity will reduce. So statement C is wrong. Only A and B is correct. Answer number 1. Only A and B is correct. Answer number 1. 53. Answer number 1. Question number 30. Right. Transformer shown in the figure has N1 turns in the primary, N1 turns in the primary, and N2 turns in the secondary. Root mean squared voltage of primary and secondary voltages are V1 and V2. So what can you say? Very simple. V1 over V2 is equal to N1 over N2. This is wrong. If AC voltage source is replaced by battery with same voltage, V2 will remain the same. Wrong. If you look at this carefully, if you put a DC voltage, starting point it will change. After that there is no change in flux. No change in flux means no flux is linked. No flux is linked. EMF there will be 0. Simple. When the secondary is connected to the load, the current in the secondary will not depend on the load. Wrong. If you connect it to the load, potential difference is there. When resistance changes, current will change. Right there. The potential difference V2 is created by induction. The potential difference V2 is created by induction. But depending on the load resistor, the current will change. Depending on the load resistor, the current will change. Right. The only reason why the core becomes warm after some time is the heat generated due to resistance of the coil. Due to resistance of the coil. Right. Now what will happen? The only reason, only because of this. No. Why does the coil heat? Why does the coil heat? You can see here it stepped down. Step down, voltage reducer. When voltage reduces, to keep the power constant, current will increase. When current increases, I squared R will increase. When I squared R increases, there is going to be power loss, heat loss. Okay. Next is what? Eddy current formation. Eddy currents are formed opposing the change in flux. This also will generate heat. So here don't forget, eddy currents are formed. Eddy currents will form, producing heat. Producing heat. So when they say only reason, that's wrong. If the core is removed, V2 will decrease. So guaranteed. The moment you remove the core, the magnetic flux linking will reduce. When the magnetic flux linking reduces, voltage will reduce. Correct. Statement 5 is correct, right there. When the core is removed, the magnetic flux linking the secondary will reduce. The magnetic flux linking the secondary will reduce. Therefore, the EMF V2 induced will also reduce. Therefore, the EMF V2 induced will also reduce. Right. Okay. Graph shows the variation of electric potential. Don't forget. E is equal to minus delta V over delta X. Potential gradient. Here gradient is 0, negative, 0, positive. Electric force equals electric field strength into charge. Let's find the electric field. Here 0 means electric field 0. Electric field 0 means electric force also 0. Right. Negative, negative, positive, force is positive. 0 means 0. Positive means negative force. So, one is positive, one is negative. Right. Looking at this, what can you say about the gradient? Larger gradient, here of course, smaller gradient. Smaller gradient. Large gradient means larger force. Smaller gradient means smaller. The correct answer, answer number 2. It can't be the same size. Huh? Can't be the same size. Okay. A car travels at speed 20 meters towards the stationary source. Source is stationary. Car is traveling towards. So from this source, sound waves are coming. Velocity v. That produces sound at frequency 1 kilohertz. 1 kilohertz. Waves that are reflected from the car return to the source. So F dash. Temporary observer. Then this becomes a temporary source. Then this becomes a temporary source. And this becomes a stationary observer. F double dash. Approximate value of the beat frequency is the emitted frequency is F. Received frequency is F double dash. Difference is beat frequency. Let's look. F dash. Velocity of sound with respect to observer. V plus 20. Velocity of sound with respect to source. V. Actual frequency 1 kilohertz. Reflection part. Velocity of sound with respect to observer. Observer is at rest. V. Velocity of sound with respect to source. With respect to source V minus 20 into whatever incident here F dash. F double dash is V over V minus 20. F dash is V plus 20 divided by V times F. V cancel off. Simplify this. F double dash V plus 20 divided by V minus 20 into F. Simplify this. F double dash 320 plus 20, 340. 320 minus 20 is 300, 1 kilohertz. Simplify this. 17 divided by 15 kilohertz. 17 divided by 15 kilohertz. 17 divided by 15 kilohertz means what? Here you have 1 point. For 20 you have 1, for 50 you have 3 kilohertz. Kilohertz. Three, right. What's your beat frequency? So beat frequency will be F double dash minus F. 1.133 kilohertz minus 1 kilohertz. 0.133 kilohertz multiplied by 1000. 133 hertz. 133 hertz is answer number 5. right there. The car will initially act like a temporary observer. The car will initially act like a temporary observer, and then it will act like a temporary source. Then it will act like a temporary source, causing the receiver to receive sound. Causing the receiver to receive sound. Causing the receiver to receive sound. Okay, no? Right. A particle is moving in a circle with constant velocity v. The magnitude of the change in velocity of the particle between P and Q is. Now remember, we drew the vector diagram in theory. Delta V is 2V, think carefully. Here, when you build the velocity, 2V sine theta divided by 2. But theta is the angle made at the center. So 2V sine 20. Change in velocity is 2V sine 20. 2V sine 20. Right. Now for this, please go and check your note. In your vector note, in your circular motion note, this is there. Change in velocity. The furthest point of distinction for a long-sighted person, long means is infinity, far point. This person uses a magnifying lens, simple microscope, to view close objects. He finds that he can see a clear magnified image of an object if it is held anywhere between 50 to 60. Anywhere between 50 to 60 he can see from the lens, but nowhere else. So here magnifying lens means convex lens. 50 millimeters, 60 millimeters means 50 to 60. 50 to 60. 50 forms close by, 60 forms far away. 50 millimeters image will form, image of lens is object for eye. This is the near point. This is the near point. Clear? And here, if you keep the object at 60 millimeter, light rays will seem like to come from infinity, which will converge on the retina. Which will converge on the retina. So this will be your far point. Far point is infinity, right? So they are asking least distance of distinction, that's your this distance here. So if you apply equations, 1 over V minus 1 over U equal 1 over F. Apply for the lens. Object is at 60, image is at infinity. Focal length of the lens minus 60 millimeters. From here we go here. 1 over V minus 1 over U equals 1 over F. Object is 50, image we don't know. Focal length minus 60. 1 over V is 1 over 50 minus 1 over 60. Common denominator 300, 6 minus 5. 1 over 300. From this, V is equal to 300 centimeters. Least distance of distinction 300 millimeters. Mm. 300 mm. Correct answer is answer number 4. Right there. When the object is kept at 50 centimeter, image forms where the eye can see. when object is kept at 50 millimeter, image forms where the eye can see. Which is the near point. Which is the near point. If the object is kept at 60, image forms at infinity. If the object is kept at 60 millimeters, image forms at infinity. Image forms at infinity. Which is the far point of the eye. Now, that's the whole idea. You might question, 50 can't go to infinity. If 50 goes to infinity, then 60 will be, if 50 goes to infinity, then 60 it will be behind, on the other side, image. You can't see. Always image from the lens should be in front of the eye. So 50 means image forms behind. 60 means image forms at infinity. It's still in front of the eye. 50 means image forms in front of the eye. 60 also image forms in front of the eye. The eye can see. Clear? So therefore remember, 50, if I keep the object at 50, image is formed at the near point. If I keep the object at 60, image is formed at infinity. Okay? Right. As shown in the figure, a small beaker contains a piece of wood and a piece of stone floating in water inside a large beaker. Inside a large beaker. The density of the stone is larger than that of water, and density of piece of wood is smaller than that of water, right? So wood will float. Consider the following statements made about the height h of the water level inside this height. When the stone is taken out and dropped, water h decreases. True or false? The moment you drop the stone will start to sink. Sinking means upthrust is less. Upthrust is less means displaced volume is less. Displaced volume is less means it will drop. Level will decrease. Statement A correct. When the piece of wood is taken out and put in water, H remains unchanged. Correct. Inside os is floating, outside os it is floating. Total weight still. Level does not change. When the stone and piece of wood are taken out, tied together and put, if they go to the bottom of the beaker, H will increase. If they go to the bottom of the beaker, that means are they sinking? Are they sinking? Yes, they seem like sinking. Here sinking means level drops. Statement C wrong. A and B correct. Answer number 2. So how do you remember this? Sinking means level drops. Floating means, somehow floating means no change in level. No change in the level. Okay? No change in the level. Right. MCQ 20. MCQ 20. A semicircular conductor PQR having uniform cross section is placed vertically in a horizontal magnetic field as shown in the figure. Conducting rod OA pivot at the center moves in semicircle at constant angular speed. So here let's say omega. PQR and OA are made from the same material. An ammeter is connected to two ends OR. If end A touches PQR, the EMF across OA and the current I will best represent by. Right. Rod is rotating in a magnetic field. EMF is equal to, have a look. So, half radius, length, have they given the length? No. I take as L. Half L squared omega. Half L squared omega times B. Half L squared omega times B. So current will pass through. This is going with omega. Okay. So this arc length, what can you say about this arc length? L theta. What can you say about the current? Current is equal to resistance. Half L squared omega B. Resistance here is rho. Total length is L plus L theta divided by A. Rho L over A. Take L out. You take L out. I is equal to L omega B divided by 2. 1 L cancel off. Rho 1 plus theta times cross multiply A. L is constant, omega constant, B constant, A constant. What is A? Cross sectional area of the wire. But theta will change. Theta increases, current will reduce. Right. Nice. Also you can see L squared omega B. L squared omega B. So as it rotates, L squared omega B is constant. But only from here to here, current will be there. Here to here, current is not there. So your correct relationship. Here, this is correct. This is correct. Here, current is inversely proportional to theta. Inversely proportional to theta. Therefore, the drop can't be a straight line. Correct answer is answer number 1. It can't be this. Can't be straight line. So here EMF never changes. Current will drop. And when it's not in the cycle, no current. Then again current will drop. Then no current. Current will drop. Theta very small means current is very large. Right there. When the rod is rotating, the induced EMF created by the rod L, the induced EMF created by rod L remains constant. But only for half a periodic time it remains in contact. Only for half a periodic time it remains in contact with the metal. Understood, no? From here to here only contact with the metal. Therefore, current will remain only for half a cycle. And it will change with angle theta. Therefore, it is a non-uniform variation drop of current. Okay. The sonometer shown in the diagram consists of two stretched thin metal wires W1 and W2. One end of W1 is attached to nail A and the other end carries a mass M as shown. Right. This is your test wire or reference wire. This is your test wire. Right. The pulley P is smooth, W2 is kept under tension by fixing a nail RNS. Right. When W1 is plugged in the middle, the wire vibrates at the fundamental mode. Draw the wave pattern. There you go. The wave pattern is drawn. If you want, you can draw this in thick line as well. There is no problem. But please draw it symmetrically. Very important. Right. How is a stationary wave formed? So how is stationary wave formed? incident wave superimposes the reflected wave having the same velocity, frequency, but a phase change of pi radians. Incident wave superimposes a reflected wave moving with the same velocity, frequency, but with a phase change of pi radians. That will create a stationary wave. Okay, now? If L naught is the distance between BC, write the relationship between the wavelength and this. So lambda naught divided by 2 is equal to L naught. Lambda naught is equal to 2L naught. Lambda naught is equal to 2L naught. Right? If T is the tension and M is the mass per length of wire W1, write an expression for the fundamental frequency. So V is equal to F naught lambda naught. V equals T over simple n. Lambda naught is 2L naught. F naught is 1 over 2L naught. Square root T over simple n. Right. The length xy corresponding to the fundamental frequency of vibration of W2 in resonance with W1 is L0. That means W1 wire and W2 wire are resonating with each other. Suggest the experimental procedure to obtain capital L0. Capital L0. The length xy corresponding to the fundamental frequency of vibration of W2 in resonance with the fundamental frequency of W1 is L0. Right. So what do you do? So we are going to vibrate wire BC, move the bridges between wire W2 until the paper rider flies off. Bring the bridges XY close to each other. Vibrate the wire W1 and move bridge Y and place a paper rider. So bring the bridges XY close to each other, place a paper rider in between, vibrate via W1 and move the bridge Y until the paper rider flies off. Now there are many reasons why the paper rider can fly off. Repeat the experiment. Measure the length between X and Y and find the average balance length. So you bring the bridges XY close to each other, vibrate W1. Now this is W2, vibrate W1. Move the bridge Y until the paper rider flies off. Now there are many reasons why the paper rider flies off. It might not fly off at the same location. So you repeat the experiment for many times, measure the vibrating length, find the average vibrating length, that is your L naught. Here, find the average vibrating length, that is your L naught. Right. M is 4 kg, that's connected to W1. What is the fundamental frequency of vibration of W2? Resonating. F naught is equal to 1 over 2 L naught, 12.5 centimeter. Convert to meter. Tension is equal to 40 divided by mass per length 4 10 to the power minus 3. 100 divided by 25, 10 to the power positive 4. Simplify it, 4 10 to the power 2. 400 hertz. W1 has 400 hertz. Resonates with W2. Therefore, W2 frequency is also 400 hertz. W2 frequency is 400 hertz. Okay, no? Right. The value obtained for capital L naught, this is for W2. In B Roman 1 is 20.2. So frequency inversely proportional length, 400 is 20.2. If the length between X and Y is changed to 20 centimeter, X and Y is W2, find the new fundamental frequency, 20.02. Divide the first equation by the second equation, or second equation by the first equation. 2 divided by 1, F dash over 400, 20 divided by 20.2 divided by 20, 1.01, F dash, 404 hertz. Now, W2 is vibrating with 404 hertz. W1 is vibrating with the fundamental frequency 400 hertz. Right. Now, we both the wires are vibrated. Beat frequency obtained. Simple. Beat frequency is a slight difference in the frequency. 404 minus 400. What's your answer? 4 hertz. 4 hertz is your answer. Right? Essay question. Now, just like last time I told you, it's a very interesting paragraph, but don't go and read the full paragraph. Look at the question, come back and check and see whether you have the answers here. Right. So if you go back to the question, if you are inside a house during lightning, these two things you should avoid doing. Thundercloud is formed by strong updraft. Of warm and humid air. The humid air expands as it rises and temperature decreases. Usually thunderclouds have two main centers of charge, with the lower charge being negative and the higher charge being positive. Right. Cumulonimbus cloud. In this figure, negative charge center and positive charge center are slightly at a height h1, h2 above the ground. The magnitude of the electric field intensity under the thundercloud is one of the factors determining the possibility of lightning. Because the earth is a good conductor compared to air, an approximate value for this electric field can be calculated using the technique of method of imager. Right. A charge minus q will produce a positive charge on the surface of the earth. So minus q means it will produce plus q. It can be seen that the same pattern lines of force in figure 2a will be obtained if the earth did not exist and a positive charge minus q was placed as in figure 2b. So here mirror image. Here minus q means here plus. Plus to minus field lines will go. This and this are similar. Here also minus q, plus to minus field lines are coming. This is same as this one, but this part is imaginary. Here h1, here h1. Lightning. Right. So electric field is created by both the charges. Lightning could cause human deaths and property damage. To save buildings from lightning, lightning conductors are fixed to the highest points of the building. A conductor like this is point N of one side and the other side is connected to a thick copper strip. Runs down the building. Lower end of the copper strip is grounded. What should not be done during lightning? A discharge can be carried out into the house through power lines, telephone wires, or even water power lines. Therefore, we should avoid using electrical equipment such as television, telephones during lightning. If you are outdoors, avoid taking shelter under isolated trees or shacks that are obvious targets. When lightning stroke hits the tree, the large current flows along the wet channels in the trunk, and it may enter the person who is either standing near or leaning to the tree. This current that enters the tree subsequently flows along the surface of the ground. Potential difference produced between 2 points on the ground about 1 meter apart can result in a fatal current flow between animals or people. One can minimize the effect of such potential difference by keeping one's feet together. Right. If you are inside a house, 2 possible things you should avoid. I will highlight these. Here you go. Avoid using electrical equipment, telephone wires. Avoid standing under isolated trees or shacks. There you go. This you can write here. Done. If you are an outdoor, why is it dangerous to stand near a tree during this? Why is it dangerous? Large current flows through the wet channels in the trunk, and it may enter the person who is either standing or leaning on the tree. This current that enters a tree subsequently flows along the surface of the ground. Potential difference produced between 2 points can be fatal. So this part you can write there. This part you can write here. Okay, now. To protect buildings from lightning, lightning conductors are used. Give reasons for the following. Open end of a lightning conductor should be pointed. So why the open ending should be pointed? Pointing conductors, surface charge density will be very high. Surface charge density will be very high near pointed places. Surface charge density is going to be very high. So from these pointed locations, what will happen? Corona discharge will take place. Corona discharge will take place. Is it clear? So when this is striking, corona discharge will take place. Right there. Near the sharp edge, electric field strength will be very large. Near the sharp edge, electric field strength will be very large. Because the surface charge density is very high. Because the surface charge density is very high. Right. Lightning conductor should be properly earthed. Lightning conductor should be properly earthed. So grounding means what? Sending the excess charge into the earth. Right there. Along the conductor, the excess charge will move towards the earth. Along the conductor, the excess charge will move towards the earth, to the earth. Okay, now? The connecting copper strip has to be thick. V is equal to IR. Rho L over A. Very thick means electrical resistance will be very small. So the whole objective is that When the copper strip is very thick, resistance will be low, large currents can pass through, right there. When the area is large, the resistance in the conductor will be small. The resistance in the conductor will be small. When the resistance is small, large currents can easily pass through. When the resistance is small, large currents can easily pass through. Why do the air masses expand, cool, as they ascend? Ascend means going up. So why do they expand? When the air masses are going up, pressure reduces, volume expansion will take place. Right there. Roman 4 part A. Roman 4 part A. Pressure increases, pressure reduces, volume increases. Right there. As the air masses move up, the atmospheric pressure will reduce. Atmospheric pressure will reduce, causing the volume to increase. Right. So next is, why is it cooling down? It temperature decreases, so it will cool down. Right there. The temperature reduces as it travels upward. The temperature reduces as it travels upward. Therefore, cooling will take place. So if you look at this delta Q, delta U plus delta W, so if you look at this, here they are telling you humid air expands and it rises and the temperature reduces. Right. So because of temperature, so as it rises, temperature reduces, cooling will take place. Right. Using the method of images, show that the magnitude of the resultant electric field intensity at point B in figure 1. Point B in figure 1. Point P in figure 1 is given by this relationship. Right. So first things first. Negative charge, this is H1. Here positive charge, H1. Positive charge, H1. Because of this point charge, the electric field here at point P. So electric field at point P, forget about the minus sign, we don't put signs. 4 pi epsilon naught h1 square times 2. If I keep a plus 1 coulomb here, if I keep a plus 1 coulomb there, positive, negative, attractive in that direction. Positive, positive, repulsive. So this is the direction of the electric field. Same way now, here plus q at a height h2 minus q at a height h2. Point P here, keep plus 1 coulomb. Negative, positive, attractive. Positive, positive, repulsive, opposite direction. So electric field at P due to plus Q. This is due to minus Q. Q over 4 pi epsilon naught H2. Both are in the same direction, multiply by 2. This is downward. What can you say about the resultant? H2 is smaller, no? H2 squared. So resultant electric field at P is 2q 4 pi epsilon naught h1 squared upward direction, 2q 4 pi epsilon naught h2 squared downward direction. Bring all vectors in the same direction. Q divided by 2 pi epsilon naught h1 squared upward minus q divided by 2 pi epsilon naught h2 squared upward. Bring all vectors in the same direction. Q divided by 2 pi epsilon naught 1 over h1 squared minus 1 over h2 squared. Right now, because of this negative charge, if I keep plus 1 coulomb here, attractive, plus plus repulsive, so total electric field here is given by this. This is your mirror image method. Because of the plus q here, plus q there means minus q here, resultant electric field can be found. Then you can add both the effects vectorially. Because of this negative charge, it's going to be upwards. Because of the positive charge, downwards. Both are in opposite directions, bring them in the same direction. So here direction upwards, resultant electric field at P. Resultant electric field at P. So correct? Right. Right there. We find the electric field due to each charge separately on P. Due to each charge separately on P. Using the image method. Using the image method. And then we vectorially add it. And then we vectorially add it. Right. Take Q20, H13, H26. Calculate E. What is the direction of the field? So as far as I'm concerned, it's upward. Q divided by 2 pi epsilon naught 1 over h1 squared minus 1 over h2 squared. Q is 20. 1 over 2 pi epsilon naught is 1.8 10 to the power 10. 1 over h1 squared is 9 10 to the power 6. 1 over h2 squared is 36 10 to the power 6. Simplify this. 36 10 to the power 10 divided by 10 to the power 6. Common denominator 36, 4 minus 1. 36 cancel off. 3 10 to the power 4 Newton per coulomb in the upward direction. 3 10 to the power 4 Newton per coulomb in the upward direction. I have marked direction upward. Upward direction because earlier also already found. Upward direction also earlier found. Suppose a single lightning stroke transfers a charge -5 through the potential difference of 10 to the power 8. Calculate the energy released by the electric discharge, assuming potential difference remains stable. So, work done is potential difference multiplied by charge. Here 10 to the power 8 minus 5 minus 5 10 to the power 8 joules. So, what is happening here? The work done by the field. Work is done by the field means minus. So, energy release. Five 10 to the power 8 joules. 5 10 to the power 8 joules. State 2 moles of dissipation of energy. Sound, heat. These are the two ways when lightning strike occurs, how the energy is dissipated. Right. During lightning, cattle standing on the ground have high risk of getting killed, even in the absence of direct light. Suggest the reason for it. Now the reason is, on the earth there are equipotential lines. On the earth there are equipotential lines. So what happens is, if a cow stands on minimum 1 meter apart, what happens is you end up having a potential difference. Because of this potential difference, there will be a charge passing through. Right. Right there. When the legs are kept 1 meter apart, a potential difference is developed. So when there is a lightning strike, instead of along the ground, charges will flow through the animal. Instead of along the ground, charges will flow through the animal due to least path of resistance. Okay, no? So if the legs are more than 1 meter apart, there is a potential difference. So lightning strike, current will go through what, or discharge will go through the animal. Why? Least path of resistance. Okay, no? Least path of resistance. Right. So what have we done? We have concluded week 6. So 60 times 6, how much? 360 MCQ. 18 structured essay, 18 essays. 18 essays, right? So what we'll be doing next week is, next week I'll be doing, every week I gave day 4 papers. So week number 2, week number 3, week number 4, week number 5, and week number 6, all these day 4 papers I'll be discussing. So next week I'll be discussing all the day 4 papers in all the weeks given. So once we finish this, we have completely done all the papers up to 2005. Okay, no? Right. Okay then. So as promised, now in the 5th week, guaranteed we'll be doing this. So here you go. We'll be doing this next week. Right now? Okay. Okay then. Stay home safe. Make sure that every step you take is a movement forward. You are trying to push harder towards your final goal. And keep working with the same intensity. Guaranteed, results will keep moving in, and you will see a difference in what you are doing. Okay. Stay home safe. Keep working. Take care. Good night.